So now we're going to look at how we do binary subtraction. And in many ways, binary subtraction is actually easier than binary addition because there are fewer rules to remember, and most of the rules are a lot simpler. This last one that says borrow is the only one that might confuse you. So to begin with, let's look at a sum that only uses the first three rules. In this case, the number at the top is always either bigger or the same as the number below. And this makes binary subtraction really simple. So the first column, the units column, 0 minus 0, the rule says we put a 0 in there. The next column, 1 minus 0, we can see the rule says the answer is 1. And finally, 1 minus 1, the answer is 0. And we can test that like we normally do by converting back to decimal. So this is a 4 and a 2. That's 6. This one's just a 4. 6 minus 4 is 2. And we can see here that the answer is indeed 2. So here's a binary subtraction which on the face of things would seem to be much more difficult. These are two 8-bit numbers, so anything up to 255 is represented by these binary numbers. But actually, subtracting these is very simple because we only use the first three rules here. So we can very quickly fill in all the columns. And I'm not even going to check this one. I know it's right. So now let's look at a subtraction where, in at least one of the cases, the number at the top is not bigger or the same as the number below. So now we're going to have to use the fourth rule, which says borrow. Let's begin on the right. 1 minus 0 equals 1. So now we move to the 2's column. We're trying to take 1, 2 here away from no 2's, and we can't do that. So just like in decimal subtraction, we're going to need to borrow some numbers from the next column along. So if I was to cross this out, that means we've got no 4's left now at all. What do we put in this column? Well, we could write 2 1's like this, or we could write a 2, because this column is worth half of this column. Now we can do this subtraction. 2 minus 1 is 1. We've got no 4's because we borrowed them over here. And we took 1 away, leaving just this 2 here. 0 minus 0 is 0. 1 minus 0 is 0. We can now convert and see whether our sum is correct. So the original number was 8, 4, and 1. Which is 13. The number we were taking away was 8 and 2, which is 10. 13 minus 10 leaves 3. How can we see that the answer is 2 and 1 makes 3? So that's correct. Let's do one more that uses the same technique. These numbers are slightly larger now, 5-bit numbers. So starting on the right, 0 minus 0 equals 0. 1 minus 0 equals 1. 0 minus 1, well, we can't do that, so we need to borrow. We're going to borrow from the 8's column, and we're going to put that in the 4's column. The reason I wrote a 2 here is because the 4's column is worth half of what's in the 8's column. 2 minus 1 is 1. Now in the 8's column, we've got no 8's at the top, and we're trying to take 1 away. So once again, we have to borrow. 2 8's make 16. We've borrowed 16 from here, so we write a 2 here. 2 minus 1 equals 1. And then our final column, 0 minus 0 is 0. We can check this, as usual, by converting the binary numbers to decimal. Here we've got a 16 and an 8 makes 24, and a 2 makes 26. Here we've got an 8 and a 4, that makes 12. 26 minus 12 is 14. And we can see in our answer we've got an 8 and a 4 makes 12, and a 2 makes 14. So what happens if, when we need to borrow, there's no number available in the next column? Well, it's simple. You just keep going along until you do find a number you can borrow. I'll show you with this example. We've got the binary number for 12 at the top and the binary number for 5 at the bottom. The first column wants us to subtract a 1 from a 0, and we know that we need to borrow. But the next column has a 0 in it. We can't borrow anything from here. So instead, we jump along to the next column that does have a 1 in it. So the 4's column becomes 0, and the 2's column now has 2 in it. Now we can borrow from the 2's column. We're going to take 2 from this column. We're going to put it in here. So just to recap what we've done here, we couldn't borrow from here, so we jumped across and borrowed 4 from this column. That means we had to write a 2 in the 2's column because 2 2's make 4. Then we straight away borrowed 1 from there and put it into the units column. Again, writing it as a 2 because this column is worth half the value of this column. Now we can continue with our subtraction. 2 minus 1 is 1. 1 minus 0 is 1. 0 minus 1, well, we must borrow. 2 minus 1 is 1, and our final column is a 0. Let's check this as normal. 8 and 4 is 12. 4 and 1 is 5. 12 minus 5 is 7. And this binary number is 4, 2 and 1, which makes 7. Okay, one last time. Here we have a big binary number. It's worth 16. And below we have a smaller binary number. This one is worth 13. But in most cases, we've got a 0 on the top row. So we know we're going to have to do a lot of borrowing. Start with 0 take away 1. We have to bounce all the way along to the 16's column before we can find a number that we can borrow. But that's fine. We cross it off. We bring it into the 8's column. Now, we cross it off and bring it into the 4's column. Same again. And finally, we borrow from the 2's column and put it into the units column. Now we have numbers where we need them, we can do our subtraction. 2 take away 1 is 1. 1 take away 0 is 1. 1 take away 1 is 0. 1 take away 1 is 0. And 0 take away 0 is 0. You might remember at the beginning I said this number is worth 16 and this one is worth 13. 16 minus 13 is 3 and our answer is 3. There is a possible shortcut you could employ and you might have spotted it. I'll show you now. Instead of writing all the 2's and then crossing them straight out and writing a 1 above them, we could just see that we need to borrow, jump across to the column we need, cross it out and write a 0, and then just write the 1's in. So we need to write a 1 in every column leading up to the column we're working on, and then we write a 1 below it. Now when we finish the sum, 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 1 is 0, 0 minus 0 is 0. We get the answer we need, 3.